Right there. So welcome everyone and happy holidays. So this is the 8th Zero Knowledge community call. And I'll give a quick introduction on myself because I'm probably a new face to many of you. So I'm Owen and I'm a developer relations contributor at DevHub, and I'll be moderating this call. So next slide. So if you haven't attended one of these community calls before, I'll just give a rundown of the purpose of them. So it's a space to discuss what's happening with ZK on there, and to help shape ideas into becoming proposals. Ideas and proposals are normally first discussed in the ZK Telegram group chat, which can be found here. And then you should go ahead and post a formal idea or solution to the ZK community feed, which is here. So then once you post an idea or solution, members of the community should give their thoughts on the proposal, and the members of the work group will assess the proposal and give attestations whether the proposal should be funded or not. So how are these calls formatted? They're mostly a free discussion, but there's proposed topics to them. And if you want to propose a topic for the next call, you should drop it in the Telegram group chat or reply to one of the tweets announcing the next call. And we post all the announcements on our Twitter, which is there. I'm sharing all these links in the chat. So participation, everyone is welcomed and encouraged to participate. If you have a question or a point you want to discuss, please just speak up at the appropriate time or leave a message in the chat if that's more comfortable to you. So what is the role of myself in this call as the moderator? So I'm just here to take notes, encourage participation, and make sure that everyone has an opportunity to speak. What I won't be doing is making any decisions or assessments on ideas or proposals here. And in the future, if you want to take the lead on these calls as a member of the community, please just let me know. And yeah, just a note that this call is being recorded and it will be shared on YouTube afterwards. So onto the topics. So these have been the topics that have been proposed for this month's call. We have some updates from Electron Labs and their integration with near data availability. We should have Garvit here, I believe. Some updates from Opact, and there's been a proposal made by Reclaim Protocol, and I believe Subhash is on the call to talk a bit about that and answer some questions. Then recently at NearCon, we had the announcements of ZK WASM and Starsight, and I believe we have some people from the Pagoda team to answer questions on these. Then next up, NDC private voting. If you voted in the NDC elections, you will have seen that I could see everyone's votes and everyone could see everyone else's votes. So should a ZK proof voting system be implemented, I believe they have some funding to give out to implement this. I see Garvit just joined, that's great. And then the topic of ZK Light Client has also been proposed. And then these are just suggestions. If you have anything more you want to speak on, just go ahead and start up the conversation. Are you ready to talk about Electron Bridge, Garvit?
Yeah, I'm actually ready. I can start.
Great. Do you have anything you'd like to share?
Yeah. I'm just actually sharing my screen. If you give me a second.
Okay, great. You should have the permission to share. Let me know if you don't.
Yeah, can you guys see my screen?
Yes, I can see it.
All right, like if anyone can't see, let me know. Otherwise, I'll just assume everyone can, and I'll start the talk. All right, so yeah, basically just to give you some background, like Electron builds a lot of ZK stuff, and what one of the key innovations we have built is the Electron ZK Light client, which is basically a ZK prover for the near light consensus, right? So this is something we have talked about a lot in the past. So I'll assume that everyone is kind of aware of that. But what I wanted to talk about today is one of the applications or one of the first integrations we have done with this technology. And what we've done is basically integrated the Near ZK Light client with Near DA, which was recently launched. And I'll just talk a bit about what this integration is all about and why it's useful. So just to give you some context, in fact, let me try to zoom in here if possible. Yeah. So basically, Near has launched a DA solution, and we talk about the architecture of the DA solution. The way it works is, if any rollup wants to use the data availability services of the Near protocol, they can do that by posting data to Near consensus, just like how any DA layer works. And what's important here is that if the rollup is actually really interested in getting as much security possible from the Ethereum protocol, which is what these rollups try to do a lot of times. So what they ideally should be doing, what the ideal security model is that the rollup should be able to prove to the Ethereum rollup contracts. So the rollup sequencer should be able to prove to the Ethereum rollup contracts that the data has actually indeed been published on Near protocol, right? So now what happens right now is that in order to check that the data has indeed been published on Near protocol, uh, the rollup sequencer is ideally required to run a Near light client in order to track the Near consensus. Yeah. Now, this obviously means that the rollup sequencer is kind of becoming uh, the center of security here. The rollup sequencer could fake inform the contracts on Ethereum that the data has indeed been published on Near, but it actually hasn't been published, right? So the security is completely in the hands of the rollup sequencer here. And the reason this is the case right now is because verifying Near consensus on Ethereum is extremely gas expensive. So you can't really do that. So as some of you might know, basically we've built the ZK client, which allows you to track the consensus, the Near consensus on Ethereum quite cheaply, orders of magnitude cheaply. So we are able to post these data inclusion proofs directly on Ethereum in a completely trustless manner. So that basically means that the rollup contracts on Ethereum can directly pull these inclusion proofs from the ZK Light client on Ethereum without having to rely on the sequencer to actually do this job. So that essentially means that if you compare this with the older architecture that I just presented, and if you compare these two, uh, the fisherman and the need for basically maintaining an off-chain system to track Near consensus is now gone. You can directly put Near consensus proofs on Ethereum, which basically removes the need to trust the rollup sequencer. You only need to trust the Near consensus now. So you're transferring security from the sequencer to the Near consensus. So that's kind of what our solution is. That we're basically removing the need to trust the rollup sequence. So it's kind of a an additional security feature for Near DA. And so this is like with Near DA, this is available as an additional security option. So if you're like a rollup which is planning to use Near DA, you can integrate this today and start getting that additional security. So we have already released the docs and the code for this, and this is already deployed on mainnet beta as well, pending audits. So which means that this is like ready to be tested out. Uh, I'll just kind of open this. Yeah, this one. I hope I change the screen. I hope everyone can continue to see that. So yeah, this is a documentation we've released, which kind of talks about what I just mentioned, that we have given you all the integration scripts, so you can go through the code that is available on GitHub and start the integration process. So yeah, I mean that's something we've built, and yep. That's what I wanted to present about this integration. Happy to take any questions at this point.
Does anyone have any questions on that? No, looks like no questions. Okay, thank you for sharing that. And so next up, do we have any? Do you want to say anything more on that, Garvit?
Yeah, that's it. Like, if any questions, let me know. We'll be happy to take them.
All right, thank you. So do we want to go ahead and have the updates from Opact? Pedro,
Yeah, sure.
Want to take that? Yeah.
Yeah, sure. Sounds good. We do not have a PowerPoint presentation ready because it's just a quick update, but I feel like it's nice to bring it to you guys. So on our last call, which was about a couple months ago, I think it was previous to NearCon still, we talked about two main things. So Opact we're finishing the deployment of our version in Cadena, which is similar to what we have on Near, but with a couple more flexibility on what you can transfer regarding tokens and everything. And I don't think that is that much relevant to our discussion. But if you guys want to know more, just reach out to us and we can talk more. But we've started to develop a system to do ZK ceremonies using Fala network on Polkadot. And I think that might be interesting for each one of you guys that might be using Graph 16 or struggle with doing ceremonies. João could talk a bit more if he wants to about it, but we started the prototype. We've worked through the stages of the ceremonies already, and probably in a couple of, like a month or two, considering that we have a small break now, we'll be finishing it. So we'll be able to generate ceremonies easily for Opact, and it on any other protocols or anything that we might want to, but that will also be open and open source to whomever wants to try it. So if you have trouble with ZK ceremonies or anything like that, we'll have it readily available for you to try it.
Yeah. On this, if I can add something.
Does anyone have questions?
I was just gonna add that you can do any ceremonies on that, both for like KZG and what's known as phase 1 commitments, and also for like circuits using Graph 16. That's entirely decentralized and should be pretty simple to do it. And it's also going to evolve into an autonomous proof builder that's going to be building proofs in a decentralized way and in a private way in the future. So that's probably like 3.5 months from now away.
And that's
nice.
it. Just a quick update.
Does anyone have any questions on the updates or about Opact generally? Okay, so Subhash, are you still here? Do you want to talk about your proposal? So recently we had this proposal to the ZK community, and we just want to revive it a bit and have a discussion around it. I'll post the link to it here.
Hey, can you all see my screen? Awesome.
Yep.
Okay, so let me take 5 to 7 minutes to warm me up to the idea of like what we are building, and then I'll briefly touch upon the proposal that we're making for Near, and then maybe so if time permits, we'll take some questions. Does it sound good, Owen?
Sounds great. Go ahead.
Okay. So Reclaim protocol, and so what we are trying to do here is making Web2 data composable on Web3, making the Web3 user data available to any application on Web3. So, and what kind of data are we talking about now? It can be user data related to identity, user data related to their financial health, and also bank balances, credit scores, their professional credentials, their contributions, even in private GitHub repos and all that. Not just that, even there's the social behavioral data. So all this data, there is a lot of data around a user that exists in Web 2, which Web 3 so far hasn't been able to access. And this is where Reclaim comes in. So we have built the infrastructure that makes this possible right now. Let me take your attention to this particular screen. On my left, so you see the IRS screenshot, and also IRS is the US tax authority, Internal Revenue Services. So if you look at it, so I logged into the IRS portal and generated a proof of my name and my address. Technically, this is 100% incorrigible proof or KYC of my name and my address, compared to the existing KYC that we are all familiar with, where we flash our driver's license, take a screenshot of it, and do a liveliness check, which has only 95% accuracy, by the way. So there are it has 5% fraudulent rate. Whereas this one, so here I am logging into the portal, and Reclaim is doing an attestation that this is my name and this is my address. So a couple of things that I would like to draw your attention to is, one, IRS doesn't, so I do not use any IRS API. If I have to get access to IRS API, I have to make a special request, and I have to wait for like 2 years before I can get any kind of approvals for that. And then the second thing is, now in that case, so did Reclaim make any changes or get any special access to the web server? No. The approach that we're taking is the user logs into the website, and Reclaim infrastructure acts as a proxy and generates attestation for that, which is one of the reasons. So recently, we announced that we announced our integration with Polygon ID. Polygon ID was facing this problem. So they were trying to onboard an issuer, and typically it would take 5 to 6 months for them to onboard an issuer. And like I said, for an issuer like IRS, it would take forever. And this is where Reclaim comes in. So with us, so now they can generate DIDs, the NFTs or the attestations in less than 10 minutes. So how does the technology work? So what we're doing is we are leveraging the typical TLS communication that happens between the user and the web server. So whenever you log into any web page, a TLS handshake happens between the user and the web server, and this is an encrypted line, which is why the HTTPS has been secure all throughout. What we do is all this communication happens in a Reclaim proxy, which acts as an attester. Now, this attester is not looking at the actual data, but only the encrypted data flow. But what it does is it does two things. An attestation that the user has made the right request to IRS portal, and that the response that's coming back is not spoofed. So just it establishes that this entire action is happening in a legit environment. But then how does the reveal happen? So this is where the zero knowledge proofs come into picture, where the circumcircuit enables us to do a selective reveal of data. The particular page on the IRS portal where my profile page, where I have my data, that particular page, which is encrypted, is sent to the circumcircuit, where the user shares the session keys of the data as a private input to this particular session. And this is where the data reveal happens. And we also do a regular expression match on only those two fields, name and address. Rest of all the fields, namely, so my the tax years that I've filed my taxes, the amounts, all that sensitive information, that's all redacted. Only these two fields are revealed. So that is how the two revealed fields plus the attestation that this happened in a legit environment establishes an attestation that this data belongs to the particular user, and they were able to access the website and generate a proof. So that is a quick 2-minute explanation of how Reclaim protocol works. So we have an SDK. So the wallet to throw the credentials is optional. If you want, the users, if they're having a repeatable credentials, we have a wallet that's being used. Otherwise, the Reclaim SDK exists that can integrate into any of the app. So we have SDKs for support for Flutter, React Native, Node. You can possibly think of. So where an instance of Reclaim pops up at a time, where you need to generate a attestation, the data, the user logs into that particular website, the data pull happens and shared with the third-party app. So that's a simple explanation to how Reclaim protocol works. So I just pause at this point of time and take any questions if you have.
I was wanting to know, Savash, is what are the trust assumptions on that tester?
Say that again. So by the way, so my co-founder Madhavan is also on the call. He's the technical co-founder. But yeah, please, can you repeat the question again?
Yeah, I just wanted to dive a little deeper into which trust assumptions the attester involves, because as I understood, it's like it's a separate party. Like, and how is it safe to ensure, and like what are like the milestones in developing it further? Is it decentralized, and how does it work?
Yeah, good.
I can take this, Suvash.
Nice.
Sure. You can go ahead now, Madhavan.
Yeah. So the trust assumption right now, I'll break this into two parts. The first is in the current setup and in the setup that we are planning on launching next. In the current setup, there is a trust assumption on us. That is, we run the nodes, we run the attesters ourselves. So you have to trust us that we are not colluding with the users. So what can we do if there is a what's the malicious activity that the attester can do? It is that they can collude with the end user and generate a proof for data that did not come from a web server. They can ask the attester to sign on something that actually did not come from the web server. That's the only thing that the attester can, you know, kind of perform malicious activity on, but they can never read the encrypted data. They cannot leak the data from the encrypted data, anyways, because all of that is protected by TLS's encryption. So that's the current trust assumption. You need to trust Reclaim protocol for, or rather, our entity to run these attesters honestly and not collude with the users. The second part of the answer is in the decentralized setting, in which today there is a trust assumption on us, but we want to decentralize that and have multiple attesters who are attesting to the same kind of request. And there's a consensus between these, quote unquote, committee members, so that there is lower probability of colluding with the attester directly.
Sorry.
Does
And the
that
idea
answer your
is,
question?
yeah, I was gonna ask how, and when you mentioned decentralization, like, are you guys thinking about going in the MPC direction, or do you have some other idea on how you would actually protect
No.
the private
We're not
users?
doing the. No, we're not doing the MPC. We are planning to go down the route of the committee. So there's going to be a bunch of randomly selected attesters who are going to generate these proofs like multiple times, then come to a consensus on the proofs that have been generated. Like if, let's say, 3 out of 5 attesters who were randomly selected say, hey, yes, this is the output that was expected, we would accept that proof.
Makes sense.
Hey, Garvit has a question.
Yeah, I just wanted to ask, like, is is the ZK proof being generated on the client side or the or somewhere else?
Yes,
Yeah.
it's on the mobile phone.
Okay, so like then why do you need like a committee to generate the proof? You said like, unless I understood it incorrectly, like the committee you said, is that for generating the proof, or is that what is the committee supposed to be doing?
The proof is generated on the client side, but um, the attestation that the encrypted data correctly came through needs to come from the attester. which is not part of the ZK proof itself, but it's part of the credential proof, if I'm able.
Okay, I would probably like want
Does
to
that
go
answer?
a bit deeper into the protocol, because like if you're generating the ZK proof on the client side, then like how can the committee sign off that the data was actually encrypted? Because then the trust
Because
assumption.
it's an HTTP proxy. So so the user, let's say, opens uber.com, and there is a response that came from uber.com. Now this data, without using Reclaim protocol, would directly come to the user's phone, and there is no way to prove that this data actually came from uber.com. Right? It could
Right,
have come from anywhere.
right.
Now, using our protocol, what happens is this request goes to uber.com, and the response comes uh, to the user via an attester. Now, this attester is an HTTP proxy, so it is looking at all the encrypted data that is going in both the directions, and it is attesting to the fact that, hey, yes, this is the encrypted response that came from the Uber.com server, and
So yeah,
puts a
the
signature on it.
so the attester is providing this attestation to the user or to somebody else?
Uh, it, it just basically just providing an attestation that can be viewed by anybody, right?
No, I'm just trying to
It's
like
actually valuable
understand.
for the
I'm just trying to
verifier.
I'm just trying to understand the sort of purpose of having an attester, because if a user is logging into Uber from his phone and pulling that data, then obviously I'm getting since my phone is connecting to the Uber server, I know that the data is actually coming from Uber, right? So I don't need an attestation there.
No,
So
no, no,
You
no.
know it,
The
but
thing is,
the verifier does not. Like if I were to verify whether you generated a proof from Uber.com, I do not know that information. You know it for sure
okay.
when you are logging into Uber, but I do not know that you didn't log in into fake Uber.com instead of Uber.com.
Got it. So the attestation, the attester is providing an attester to some third party, which is not the user, right? So that's the question I actually
Yes,
had.
that's right.
yes.
It's providing an attestation that the user made a legit request.
Right. And so the trust assumption is of course with the attester here, right?
Yes.
Right.
Yes.
Okay.
Yeah, which is what Madhavan explained, right? Now, so single attester right now versus consensus mechanism in future.
Okay.
Yeah.
All right. And like I think like in the next slide, I think you've also mentioned some performance numbers. Like if you can,
This one?
yeah, is the code available for this? Like I'm very interested in client side proving in general. So ZK Groth 16 proofs in 10 seconds on Android device. That's like that's amazing. Is this like
Yeah,
available
it's
somewhere?
open source. Yeah.
Mm,
It is github.com/reclaim protocol. I don't know where we can um, drop the proof.
Yeah, it's so if you look at the proposal that's shared, I think so it
Yeah, I'm
has
looking.
all the code, everything in it. Let me share the proposal here. Yeah, that proposal has the docs, GitHub link, everything in it.
So you use Circom to okay. Uh, okay. So what's the like you mentioned? I think you use some sort of encryption scheme here. So what scheme are you using?
Chacha 20.
Sorry, which one?
Chacha 20.
Okay. Uh,
Chacha 20 is the eh, like AES and Chacha 20 are the official uh, encryption algorithms for TLS.
right. Yeah, we actually used
So
AES a while back, like for one of the something similar we built like more than a year ago. We were using AES at that time, so I was just curious what you've used.
yeah, Chacha 20 is a stream cipher, so it's more optimal for ZK proofs.
I'm clicking on the link that you've given for circuit. It's just opening an image for me. Uh, no, I can't find your company GitHub anywhere in the proposal.
Okay, let me. It should be there, but yeah.
in the meantime, we had a question in the chat. I'll go ahead and read it out. Can the attester be an AI that is open sourced that can check whether information is sent correctly? So it can show that the attester is neutral and won't collude with the end user.
So the attester's job is not to verify the correctness of the information that is being sent, because it does not have access to the information itself. It can only see the encrypted data. So the only thing it needs to sign off on is whether the right encrypted data was sent as a part of the request and the response, but does not have any right to look into the data itself. It can only see the encrypted data. So I'm not sure if I understand the question right.
Maria, I think the question is, instead of trusting a human attester, which is where we are saying like a multiple attester is needed for consensus mechanism. So the question I guess I'm assuming is using an AI attester. And
Yes, there's no human attester. All of these are like all the attesters are like algorithmic attesters, right?
Right.
It's basically a node that's running.
Yeah, hi. I have another question. Actually, I can't find the the groth16 prover on Reclaim protocol. I see something around Gina, but is that something?
It's called Chacha 20 Sercom.
Okay. So okay. Okay, you mentioned something around AES, which I think you've pulled from our repo. Yeah, that's okay. That's great. But can you like run this on Android? Like, have you tried running this on Android?
It's live right now. It's you can actually download it on the App Store, Play Store.
Can you share the link?
Reclaim wallet.
If you go to reclaimprotocol.org, you will see the install button on the top right.
No, like what I'm like the app is fine. Like I'm asking like the performance numbers that you've given, like is the code for that available anywhere?
The app is not yet open sourced.
Okay, and the 10-second proving time you mentioned, that is for the Circom repository you've shared.
Yes.
Okay.
When running on Android.
Okay, I'm surprised. Like I didn't know people could run Circom and Android already.
Mhm.
Yeah, I would like to like personally. I would love to like check out the Circom repo. Yeah, the one that you're running on Android.
Sure thing. Yeah, we could also sync outside of this call, and yeah, you could probably look at our code if you want. It's just that we do not publicly open source it because we haven't gotten it audited yet, so don't want to put out something that's insecure out there. But happy to give you access.
Yeah.
Okay, any more questions or thoughts about the proposal?
So like how does near protocol fit into this? Like I mean, at the end of the day, that's what we're discussing.
Hey, so now if these proofs are being generated, it needs to also be used on chain, right? Now, how do we make these proofs available for use for dApps on chain is what the proposal is for. So if near dApps want to use these proofs in their flow, how can they use it? So we need to have those deployments on the near protocol itself.
Okay.
Anything more from anyone? Okay, cool. Should we move on to, I'll reshare my screen. There we go. Should be able to see that. So we have 3 more topics, and well, more if people want to discuss else. Does anyone want to speak about ZK WASM and star sites, the NDC private voting, and ZK Lite client? Just speak up, please.
I can talk about ZK WASM.
Sure, please do.
And list. How are we doing on time, by the way?
Plenty of time.
Okay. I'll try to share my screen as well. Yeah, that's cool. Yeah, should be good. Yeah, I'll try to go quickly through this prezo, maybe in like 7-8 minutes, and then leave time for questions. And I'll skip quite a few slides because they're not very useful for this audience. So, hi everyone, my name is Andre. I'm working in Pagoda on near core protocol. So Pagoda builds near blockchain. We use WebAssembly extensively to program our smart contracts. And the team that I'm working on is contract runtime team that is actually building the WASM execution environment for smart contracts within a near blockchain. Now, why are we looking at zero knowledge for WASM? Well, we want to be able to outsource provably the smart contract execution, so that basically to scale the blockchain. That's kind of the ultimate goal. Right now, we are in this situation where the validator needs to re-execute the same contract. So we have hundreds of validators running the same code to arrive to the same results. This linearly increases the number of computation with the size of the network, which is not great. Increases the cost of transactions. In ideal world where ZK Holy Grail is reached, we only need to run the transactions once and generate a proof once, and then every other validator will just check those proofs. Ideally, not for a single contract, but for a batch of contracts, or even for a collection of blocks at a time. And even further, we would have light clients that would be able to check the execution of WASM contract proofs that prove the execution, the correct execution of WASM smart contracts. So here's the end-to-end architecture of the project. So we've iterated on a few models on how exactly to go from WASM bytecode all the way to proofs. And this is what we settled on. We are using the compiler project called CraneLift, which is the tool built at Mozilla that is one of the most performant compilers for WebAssembly called WASMtime. And along with that WASMtime compiler, there is a CraneLift project that allows to compile WASM to a variety of different platforms, like x86 or ARM, or in our case, ZK Assembly. So ZK Assembly is a project introduced by Polygon Hermes team that is a friendly virtual machine that is zero knowledge compatible, for which we could generate circuits and generate proofs for. So I won't focus in this presentation about the later pieces here, but ZK Assembly is intermediate representation that's later converted into PIL, which is polynomial identity language, which is what Polygon Hermes proving systems are working with. And these PIL modules are later converted into Starks and proved by Plonky 2. But again, I won't go there. So ZK ASM virtual machine is, I guess, similar to other virtual machines out there for ZK, like Maiden VM or RISC-0 VM. It is a hand-designed machine that is easy to generate ZK proofs for. It is fully defined in software. It is a register machine with memory. There are a lot of terms here that are compiler specific. I'll show some code examples to actually bring it to life. So this is an example of WebAssembly code that we encounter in the smart contracts. This is the simplest example you can imagine, that is adding two integers, 2 and 3, and comparing that the result of this computation is equal to 5. And the reason I'm showing you to this is because we now can generate ZK ASM programs that represent the same computation. And again, this is don't feel like you have to parse all of these instructions. It's just to give you a flavor of the assembly language that we're working with, that we're compiling to from a WebAssembly. Again, if you've ever seen the x86 assembly, you'll see familiar pieces here. There are labels and jumps and assignment operations and memory stores and memory loads. So yeah, that's what we are generating. So the plan for the project is 3-stage. We're in stage 1 now, where we aim to be able to ZK prove WASM test suite. So these are tests that cover the majority of WebAssembly instruction set. So these are all operations that WebAssembly can or supports. After this stage, we'll be able to generate ZK proofs for simple WebAssembly programs or smart contracts for individual smart contracts. For example, you can imagine a smart contract that computes a Merkle proof, or does some hashing, or maybe does some encryption or digital signature. So we'll be able to prove those smart contracts in stage 1. Stage 2 is a stage where we do ZK proof for a full WASM interpreter, and you can call it type 1 prover for WASM. So we'll be able to prove, the goal will be to be able to prove the execution of WASM interpreter on arbitrary smart contract passed as an input. Right. The idea is that we'll have a single circuit that will be universal, that will be able to consume a batch of WASM programs and produce a proof that testifies to the execution of each of those, to the results of execution of each of those contracts. And this is necessary in order to batch those proofs across multiple contracts. We don't really want, in the stage 1, we need a single circuit. We need a circuit per smart contract. And that is not really scalable, at least in the concept of the blockchain consensus. For blockchain consensus, we want to have a single circuit that can work with any WebAssembly contract. And this is the goal of stage 2. Stage 3 is further ahead, which is near protocol prover. And again, the goal here is to have a circuit that takes as an input a state root of near blockchain, along with transaction data that gets included into this block, and proves that the result of executing this block of transactions is the next state root. That's the ultimate scaling solution. Then if you can recursively aggregate those proofs, you can basically say, if we start at this state root at the beginning of epoch and we execute all transactions within a day, within the epoch, this is the state root that we are going to end up with. If you want to learn more details about each of those, we have a roadmap, and I should actually share the presentation. Let me share the presentation in the chat. If you want to click on any of the links. Okay, let's move on. So where we are now, Right now, stage 1, we're close to completion. We have more than 80% of I32 and I64 opcodes passing WASM spec tests. And so that you know, WASM is, majority of WASM instructions are I32 and I64. It doesn't have any strings. It doesn't have any advanced data types. They're all built out of integers, I32 and I64 operations. So this covers majority of the WASM instruction set, which is around 130 instructions, I guess, an MVP version, at least in MVP version. We have support for WASM function call and WASM control flow, so loops, if statements, recursion, all of this works now. And there's some basic support for WASM memory loads and memory stores. There are a few things to iron out here, but we can address up to 4 megabytes of memory within those smart contracts. We have 2 benchmarks that are actually compiled directly from Rust. So that's another cool feature that we are targeting. I mean, we want our smart contracts are in WebAssembly, but people ideally would write code in higher level language that compiles to WebAssembly. And just to test, to see how far we can go, we try to keep all our benchmarks written in human readable Rust, so that you can take your program written in Rust and then compile it to compact WebAssembly, and then compile that to zkASM. So this is an example of Fibonacci computation, again, just a simple loop with additions. And another one that's interesting is SHA-256, which is actually using external library here. This is importing SHA-2 crate. And again, hash is the simple string hello world. Yeah, you'll notice some weird asserts here. This is because WebAssembly supports only I32 and I64, so we need to encode basically all characters, all hex characters as I64s. But yeah, those are benchmarks that we have for stage 1 at least. Fibonacci is working already. SHA-256 is close to be working, and we'll be starting stage 2 in January, so next month. So here are some links if you want to follow along. We have all of the code is public on GitHub under near project, under near org WASM time repo. We post weekly updates on GitHub on the project, and we also have some documentation about contributing, but also architecture of the project. And if you want to reach out to learn more, you can find us on Zulip under contract runtime stream. So feel free to drop by, ask any questions there. With that, I'm going to hand it, or well, open up for questions and feedback.
I was going to ask Andre, does Near actually have in their roadmap to implement the ZK WASM into mainnet somewhere in the future, or is this more of a experimental thing we're doing right now?
So the other topic on the discussion, which is Starsight, is the plan to move to stateless validation and later move to the ZK-proven stateless validation. You can see Bowen's presentation at NearCon for more details, like an exact plan and timeline. I mean, we know that ZK proofs are here. They are moving really fast, but they're still not yet there to be fast enough, for example, for block times that Near is targeting, which is 1 second. So there's still a lot of questions to be resolved on how to get it fast enough, how to get it audited, and the code battle tested enough. But that is the plan, at least in the long run.
We had a question in the chat from Seth saying, we're working on things around verifiable binaries and builds, and they were wondering if they could help with some of this ZK WASM. So I presume the best way through Zulip, is that?
Yeah, I would say reach out on Zulip to discuss this in more detail. I'll drop a link in the chat as well, so that don't need to hunt for it in the presentation. But yeah, that's our stream. We have like some weekly meetings, so you can join on our weekly sync and we can discuss it there. But yeah, I think the best way would be to write a post on Zulip, like describing what you are trying to achieve, and then we'll see if we can align.
Okay, thank you for that. Any more questions? Okay, perfect. I see that we're coming up on time. We only have about 5 minutes left, but there's still some topics up for discussion, like NDC private voting and the ZK Lite client. So I'm happy to hang around, and others might be, if anyone wants to discuss these topics. Just speak up, please.
Yeah, that's Mike from ZPoken team. I can give a small update regarding the zero knowledge light client that we're building. So the light client is fully ready on our site. We still don't have a solid wrapper, but we're working on it. From our benchmark, currently it takes 22 minutes to prove one block. So we're working on optimizations.
So, sorry,
how to do this.
how much time did you say?
22 minutes per block.
22 minutes per block.
Yep, that's what we have right now, and we have a plan how to make a parallelization in order to make it.
Is this code available anywhere?
Sorry.
Is this code available anywhere? I think you're on mute.
Yeah, sorry. So currently we have 22 minutes per block. That's what is working right now. You can check our repo on Git. We have a plan for the parallelization that we're working on right now. It's estimated that with the parallelization that we implementing, it will take 3 minutes per block.
Okay, would you mind like sharing the GitHub link to the repo?
Yeah, I can share it in our chat right now. Also, what I'm working on right now, or we're working on right now, is Circom, Plonky2, Circom and Plonky2 GNAR.
Yeah, in case you want to use that, we have actually built this out. We have a Plonky2 prover for GNAC, something we shipped just a couple of days back, and we are working on a lot of optimizations. And of course, like it will be free for anyone to use in the near ecosystem at least. So yeah, like please, like feel free to check it out. Like yeah.
Okay, anything more on that topic? I see. Shared the link.
Thank you, Gravity. I will check your Plonky2 GNAR, and I also just shared the link to our GitHub.
Okay, cool. Thank you. And any thoughts on NDC voting private ZK?
It depends. I think we discussed about it a bit on our last meeting, but I'm actually fairly curious to understand what is NDC's position on it. Because we actually studied it a bit, how to build an algorithm for a private voting. It is not as simple as we thought at first, but there's not that much documentation by NDC side on like what would be an actual requisite for a software that does private voting there. Do you know more about it, Owen? Ooh, good.
I'm not too familiar on the requirements, but as you can see, I shared a link, and they have like a P3 to implement private voting. I think the best way to learn more would be to get in touch with like House of Merit, or post on the governance forum asking what are sort of the requirements and what they're
Okay. But that's great.
Okay. Thank you for sharing that link. There's a contact being put in the chat. Right. Does anyone have anything more they would like to discuss about ZK? Okay, I think we will wrap it up there then, exactly on time. So thanks everyone for coming along today. It's been quite full and action-packed, a lot of updates, and happy holidays. Hope to see you around in the new year. Thank you.
Thanks,
Always nice
everyone.
talking to you guys.
Thank you very much.
Thanks for organizing.
Bye bye, guys.
Bye bye.